Okay, I'm back, and now we want to talk about what causes motion in the first place. So, Newton came up with three laws of motion. So, he came up with the first law, the second law, and then the third law. So, first, second, and then third. So, those were the three laws of motion. So, let's analyze them. The first law of motion for linear systems was that an object, once it's moving in a straight line, it wants to continue to move with a constant linear speed, and it always wants to go in a straight line. Now, if you want to change the speed, or if you want to change the direction that it's going in, you apply a force. So what would be the counterpart to Newton's first law of motion for a rotating system? So it's going to be, once you get something spinning, it wants to spin forever and ever at a constant rotational speed, and its axis of rotation always wants to point in the same direction forever and ever. So, and as an example of that, we get out our wheel again. And so this works the best if you have a wheel that doesn't have much friction on it. So if I get this thing spinning, can you see that it continues to spin? And if there was no friction, it would spin forever and ever at that, whatever that speed was that you got it going at. But the other one is a little bit more complicated, and the axis of rotation for this wheel is pointing towards you and pointing this way. So it's like this. So if I get this thing spinning and I try to rotate the wheel, can you see that I'm having a little bit of difficulty doing it? So it's hard to change the direction of the spin when it's spinning. And that is because of Newton's first law. Now, if I do want to change the speed at which this thing is rotating, or if I want to change the direction it's going in, what do I need to do? So I'm not going to apply a force, I'm going to apply a torque. So a torque will change the speed of a rotating object, or it will change the direction of the axis of that rotating object. So that's Newton's first law. Okay, what's Newton's second law? So Newton's second law is, for linear systems, force equals ma. So that a force causes a mass to accelerate. So Newton's second law, when it comes to rotating systems, is going to be not a force, but a torque. A torque will cause the moment of inertia of an object to accelerate. So we're going to use, instead of A, we're using alpha. Instead of M, we're using I. Instead of F, we're using torque. So torques will cause an object to either change its speed, and what's another name for changing its speed? Accelerating, or it will change the direction it's going in. And how would you do that? Well, you're changing the I when you do that. So that's what a torque does. Now you'll notice that this one has a yellow box around it, so I just want you to understand it conceptually. So here's a sample. If you apply twice the amount of torque on a wheel, what will happen to its acceleration? Well, remember when we did a problem where we said if you apply twice the force, what happens to the acceleration? It'd be twice as much. So twice the torque will produce twice the rotational acceleration. All right, then you've got Newton's laws, his third law. So we've done the first law of motion, we've done the second law of motion, and so now we're going to do the third law of motion. So the third law of motion says for every action, there's an equal and opposite reaction. So if you apply a force to a wall, the wall is going to apply a force against your hand. Equal and opposite. In the picture over there with the balloon, you see that the balloon is pushing gas that way, but the gas is pushing this way on the balloon. So equal and opposite. Now, what's the counterpart to this when it comes to rotating objects? So for every torque that you apply to an object, that object is going to apply a torque back on you. Okay, so this is where it gets really cool. I want you to watch this little video. It's from the movie Black Hawk Down. So if you will just go to the internet and type in Black Hawk Down Super 6-1, watch that little video, okay? All right, so what you should see is that the bad guys shoot a missile that hits the tail rotor of the helicopter. And so when the tail rotor is hit, what does the helicopter do? Did you notice that it started to spin? Okay, so what is going on in this situation here? So the helicopter engine is producing a torque on the blade. So the main rotor for the helicopter goes around and around because the engine of the helicopter is producing a torque on the blade. So the blade rotates. But according to the third law, the blade must apply a torque on the helicopter. So that would mean that yes, the blade wants to go around like this, but it wants to make the helicopter do this. It wants to make it spin in the opposite direction. Why doesn't it happen? Because the helicopter has a tail rotor. So the purpose of the tail rotor is to provide a counter torque that will keep the helicopter from spinning. And so you saw in that little video clip that if the tail rotor gets hit and stops working, then the helicopter will begin to spin as a result of that. So it's a very good example of Newton's third law of motion. Okay, let's take a break. And when we come back, we will talk about the counterpart to linear equilibrium.